Hello guys, today we're going to be doing a quick little lesson on how can we use the discriminant to determine the nature of the roots. But before I teach you about that, please take a few moments and for your warm-ups today, stop the video after you write down these problems. I want you to factor the first one and the second one to get the roots, and on the third and fourth ones, please use completing the square technique. So get those copied down, pause the video, and then when you're done, come back. All right, for the first one here, this is factorable, so we do x minus 5 times x minus 5 equals 0. Therefore, each of these would be x equals 5 and x equals 5. On the next one, this would factor into x plus 3, x plus 5. This would become x equals negative 3 and x equals negative 5. Over here for completing the square, a little more involved. We'll move the 3 over. That gives us x squared minus 8x equals negative 3. We now want to complete the square. X squared minus 8x, and as we always do, plus blank minus blank equals negative 3. Half of negative 8 squared will be 16. And use a negative 16 to balance it out. Move the 16 to the other side. This piece will now factor into x minus 4 times x minus 4. And on the other side, we get ourselves a positive 13. Since there's two of these, we can now square it. X minus 4 squared equals 13. We're now going to square root both sides. This gives us x minus 4 equals plus or minus rad 13. And to get the x alone, add 4 to both sides, and we get x equals 4 plus or minus radical 13. Last one to go here. We're going to bring over the 15. This gives us x squared plus 4x equals negative 15. Let's complete the square. X squared plus 4x plus blank minus blank equals negative 15. Half of this squared will be a 4, and also minus 4 to balance it out. Move this 4 to the other side. Factor that expression into x plus 2 times x plus 2, and this will be equal to a negative 11. We can write this as x plus 2 squared equals negative 11. Square root both sides, and we get x plus 2 equals plus or minus radical negative 11. Now remember, negative under the radical, we want to pull out the negative 1. 11 doesn't have any other perfect squares. So this is really going to be x plus 2 equals plus or minus I rad 11. And I'll bring over the 2. So our final result on this one, x equals negative 2 plus or minus I radical 11. Now, each one of these has a specific purpose. These are all different types of nature of the roots. First thing is there could be real roots, they could be imaginary. Anything without an I would be considered real. So both these 5s are real numbers. Negative 3 and negative 5, those are real numbers. Even though it's irrational, this would be real numbers. But over here, because of the I, this would be considered imaginary. I'm going to squeeze this up top. Next, the number 5 popped up twice here. This would be considered the same root, a double root, or equal roots. So I'll say this, the roots are equal because I got the same number twice. Over here, these two numbers are different. So we would refer to that as unequal. So So we've got two different roots, they're unequal. Over here, because of the plus and the minus, that would also be two unequal roots. And over here, technically, you get two of them and they're unequal as well, even though they're imaginary. Lastly, is rational versus irrational. These are integer values, they terminate, they come to an end, so they would be considered rational. These also terminate, so these would be rational. The square root of 13, if you try taking that, you get a long decimal that will never repeat, never end. That's why these would be considered irrational. And since those are imaginary, we don't have to specify rational or irrational. It's simply just imaginary. Now, we did this the long way, figuring out the nature of the roots for each of these by actually finding the roots. But there's actually a formula we can use that can determine all this without going through all the algebra. So please pause for a moment, copy down whatever work you need, and then we'll do some examples. Okay, so for the nature of the roots, there's a formula called the discriminant. And the formula, it's a simple one to remember. It's b squared minus 4ac. And those values are going to come from a quadratic function in standard form, or actually, I'll say a quadratic equation. ax squared plus bx plus c equals 0. So the a, the b, and the c values will come from the equation. All right, so for the discriminant, there's three types of values we can get. The first type, I'll start with the easiest one, is negative. If we want to put a negative value after we plug in, this tells us that the roots are imaginary. So a negative result is imaginary, and yes, they still would be unequal two roots. The next scenario is actually the easiest. This is 0. If we get a 0, that means we have real roots. If we get a 0, we get equal roots, meaning the same number pops up twice, like we had 2 roots of 5 earlier. And lastly, when you have a 0, the roots will be rational numbers. The reason for this is, if we try taking the square root of a negative number, it doesn't exist and we get imaginaries. We can take the square root of 0, so that gives us a real number, so that's why it's real. Equal, that's just going to be a 0 value only, and because we can take the square root of 0, that's why the roots would be considered rational numbers if we did it. The last case scenario is if we get a positive number. Because we could take the square root of a positive number, that would result in a real answer. So once again, the roots would be real. But since the number is any positive number and doesn't include 0, this is going to give us unequal roots. So we'll get 2 different values. And then the last part, I have to kind of branch this off again. There's 2 types of values we want to focus on. Numbers that are perfect squares and non-perfect squares. If the number winds up being a perfect square, we can take the square root, get a nice terminating number. So that's going to give us a rational, or I should say rational values. If the number is a non-perfect square, that would result in irrational roots. so this little flow chart here is what I would like you to memorize. Okay, memorize the whole thing, starting with the discriminant, b squared minus 4ac. If we get a negative result, the roots are imaginary, show's pretty much over. If you get a 0, we would identify real roots, they'll be equal, and they are rational. And if we get a positive number, you got to think a little bit extra here. The roots would be real, they'll be unequal, so there'll be 2 of them. And if it's a perfect square, we get rational results. If they're non-perfect square, irrational. Okay? Please take a moment, get all that copied down, and have this memorized for tomorrow. All right, let's look at 4 examples. Okay, example 1. So the instructions would be, determine the nature of the roots. So we don't want to actually do the whole algebraic process, although we did look at this problem earlier in the warm-up. Here's how the discriminant works. Using the formula b squared minus 4ac, we're going to get the values for a, b, and c from this format here. So if it helps you, you can put the 1 in there. So the b is equal to the negative 10. We have to square it. 4 times the 1 times the c value, which is 25. When we work this out, we get 100 minus 100, which gives me a 0. Here's how the discriminant now works. From that memorized flow chart we just wrote down, since it's 0, and I can take the square root of that and get a real number, the roots will be real. Because it's a 0, and only a 0, we're going to get 2 roots that are the same or equal, or a double root they might call it. And lastly, because you can take the square root of 0 and get 0, that would mean the roots are rational values. So right here, we now know that the roots are real numbers, it's going to be the same number twice, and they're going to be rational values. Okay, next example. X squared plus 4x plus 15 equals 0. So using the discriminant, b squared minus 4ac, we'll do 4 squared minus 4 times 1 times 15. Working this out, we get 16 minus 60, which will wind up giving me a negative 44. So based off this value, it's negative. So if it's negative, that tells me my roots are going to be imaginary. And technically there'll be 2 of them or unequal, but from the past, imaginary has been suffice. So these are going to be imaginary roots, and the show's over. So yeah, when it's negative, that's the easiest scenario to identify. Okay, for this one, once again, using b squared minus 4ac, negative 8 squared minus 4 times 1 times 3. This gives me 64 minus 12, which is 52. Based off of this number, because 52 is a positive value, I know my roots are going to be real numbers. The fact that this is not 0, that means my roots will be unequal. So we'll get 2 different numbers, 1 for each root. And lastly, since 52 is not a perfect square, that means we would get irrational values. So positive makes it real. Any number beyond a 0 would be unequal and irrational because this is not a perfect square. So that would be the response. Okay, one more scenario to look at. (2x squared minus 9x plus 4 equals 0. So b squared minus 4ac, negative 9 minus 4 times 2 this time, with another 4. This is 81 minus 32, and this yields us a 49. So because this is positive, I know the roots are real. Since this is not a 0, they're going to be unequal. And since 49 is a perfect square, the roots will be rational. So once again, anything that's non-negative will result in real roots. And since it's not a 0, that's why we'll get 2 unequal roots. And since 49 is a perfect square, that's why it's rational. All right? So that's how you can use the discriminant, b squared minus 4ac.